face.
I was just
All right, Mackenzie, question.
The domain of 27.
27.
all of 27. All of 27.
All of
27. I'm not sure what the directions were.
A, you have to find f of g of x and then the domain. And then B is g of f of x in the domain.
And B is G of f of x and the domain. Okay. Well, first of all, the domain on 27 is a negative infinity to 3, isn't it? Right? And then the domain on this one is going to be from negative infinity to negative 4 with a bracket union 4 to infinity, correct? I mean, you have x squared minus 16 is greater than or equal to 0. So you have x plus 4, and you have x minus 4 greater than or equal to 0. And then you have the regions, negative 4 and 4. If I put a 0 in there, it's obviously a negative region. Those are positive regions, so closed dot with an arrow. Yeah?
So you always want to do the domain before you substitute it in.
Yeah, because when you substitute it in, you're going to add to the domain, so you have an idea of you're dealing with restrictions right away.
But it won't change.
Yeah, it might change. Like for this one, f of g of x, f of g of x equals the square root of 3 minus x squared minus 16. Okay? So I know that the x squared minus 16 is already going to be a factor because I have to do parentheses first. So I know this is part of my answer already. Okay? And the fact that I have a 3 right here, that also adds to it. So, in fact, 3 minus x squared minus 16. So, is it plus?
Well, now that you add the parentheses,
It is. I'm not done. Yeah, I was going to do something, and then I changed my mind. I was going to distribute the negative before I do the radical. I'll draw the radical last. Okay, so if I distribute that,
but the x squared minus 16 is under its own radical.
oh, it is?
That's what they're saying.
Oh, I thought it was all in one. Oh, well, that makes it easy. I was trying to figure out how to factor that. Oh, you're saying like that?
Yeah.
Oh, okay. So that means also that not only do you have the restriction for this radical, but the other restriction is that this square root has to be less than 3 also. Does that make sense? So 3 minus the square root of x squared minus 16 also has to be greater than or equal to 0. Like you can't come out with 100 inside of here and then take 3 minus 10. So you have this as part of your answer you have to deal with, and now you have to figure out what this means. 3 greater than or equal to square root of x squared minus 16. I don't know. Square both sides. 0 greater than x squared minus 25. Negative 5 and 5. X plus 5. X minus 5. Oh, no, I'm just kind of playing around. This is going to be a negative, and this is going to be a positive. X minus 5. Yeah, and that's going to be a positive. And you want the negative region here. So when you put these two together, I think that would be the domain of your entire function, wouldn't it? I'm guessing.
Like what?
Well, this comes out of the domain of f of g of x. And combine that with the domain of g of x, you come up with the domain of the whole thing, which I think would be from negative 5 to negative 4 union 4 to 5. Well, if you look, wait a minute, negative, yeah, because I want the positive region over here, okay, for this part. So if you combine that with this picture right here, the one, the negative region, well, if you put a negative 5 on there, it's going to be to the outside, so it's still in, and we go to the left, you're going to have to stop at negative 4. 0 is not allowed to be put into this equation, okay? Even though 0 works in the equation down here, you have to go here first, get your answer, and then generate another y value from that. So it's a combination of these two together, what they have in common. If you make the master positive 4, 5, negative 4. The first one went like this. It went out, and the second one went in. So what they have in common is this region right in here. Okay? Yeah. Am I close?
What's the domain?
I would say it's this part right here what they have in common. Negative 5, negative 4, union 4 to 5. That's what I would guess. Well, I can't put 0 into this equation. It doesn't work. I can put in 4 and it'll work. 4 square root of 16 minus 16 is 0. 3 minus 0 is 3. Square root of 3 works. But if I put in 6, well, that's 36 minus 16. That's the square root of 20. But the square root of 20 is going to be bigger than 3, so it's going to be a negative inside the other radical. All right? So, yeah, you have to do both domains as you're going and find out what they have in common. Yeah? Because you're squaring the x inside this radical. So positive and negative is going to come out with the same y value with the x squared. It doesn't matter if I put in a negative 4 or a positive 4. After I square it, it's still going to be 16. Okay? So the squaring brings the other side into the equation also. All right? That was fun. Ooh, g of f of x now. Is it? I would hope so. Let's see if I can just borrow this. Should you give a shout out to Eric or not? Nah. No, I don't think so. All right. He's gone. He didn't do his homework. That's what, yeah, that's what he said. All right. Negative infinity to 3. And this one was from negative infinity to negative 4, bracket, union 4 to infinity. This one's g of f of x. The last answer must have been right because some people probably looked it up, and so we'll go with it. Square root. Square root 3 minus x squared minus 16. All right, so the first domain stays true that x has to be less than 3, otherwise you'll get an undefined right here. Okay? Next, though, if you put 3 in there, you end up with 0, and 0 minus 16 is 4i, so there's some additional restrictions as well. So we'll just take this part. We know it has to be negative infinity to 3 as part of our answer. Then we take that 3 minus x squared square root minus 16. That has to be positive. This technically is the absolute value of x, but I don't think it matters in this algebraic problem. Negative 13 is greater than equal to x. So that would be negative infinity to negative 13. So what do they have in common? Obviously this one. Is that even close? Something about the math doesn't feel right on that one. So in this case, the first one said it had to be this way of 3, then this one had to go from negative 13 and that way. So what they have in common is just the negative infinity to negative 13. Oh, it's easier because they squared it first. Well, that's why. They squared the square root. Technically, that's an absolute value, so we should have more solutions, but I think for a domain, it's going to be fine. Yeah. A 5? Is it hard? Oh, same rules? F of g of x domain, g of f of x domain? Okay. All right, what do we do first? F of g of x? Square root, the square root of x plus 5 minus 2. So this first part says they have to be from, negative 5 to infinity. Square root of 0, 1, yeah, 6, negative 4, negative 3. Yeah, it works. All right, then this has to be greater than or equal to 0. Square root of x plus 5, greater than or equal to 2. Square both sides, x plus 5, greater than or equal to 4. Greater than or equal to negative 1. I'm not sure. I don't remember squaring inequalities just as kind of like as easy as I'm doing it. It seems like there should be like a little bit of a thought process before you just square it. Negative 4 less than or equal to negative 3. Square both sides, you get 16. See, that's what I'm thinking. These are positive numbers. Positive numbers hold true when you square both sides. 4 less than or equal to 5, you square it and you get 16 less than or 25. That's the out. These are all positive numbers, so you're fine with squaring both sides. Because negative numbers, you have a problem. You have to take the square root of positive numbers. That's why. Okay, I feel better now. Negative 1, as I'm sure you do also. So it looks like it has to be from negative 1 to infinity. Does that sound right? I'm not sure how the student solutions would do this, but I don't know. G of f of x. G of f of x. Square root plus 5, square root of x minus 2. Well, again, you got the 2 to infinity thing. And this is never going to be negative, so I think you're done. This isn't ever going to be a negative number. That's the only way you can get the square root of a negative number is if this is like negative 6, negative 7, negative 8. That's never going to happen because you've already accounted for, the fact that it isn't going to be negative. So I think you can stop right there. Because if you add something to 5, it's still going to be positive. If you didn't see it there, you definitely see it in your work right here. When would the square root of x minus 2 be greater than or equal to negative 5? Always. And this is where squaring with negative numbers won't work.
But can't you just flip the sign?
Flip a sign. No, I mean you mean when you square the negative? Yeah, but this is a positive number, and that's a negative number, so that's kind of like a, I don't know if you can do that. Because if you have negative 5, let's say go 1, you square it, 25, and you're saying just flip it? Well, I don't know if we can just go around flipping things just because it works.
You always, like, you flip it, like, whenever you multiply by
You do.
negative, which is what you're doing.
Well, I think squaring both sides is a little bit more than multiplying by a negative. It's a little bit more powerful than that. Like when you square both sides, you bring in extraneous roots on some problems. So it's kind of like one of those, yeah, you can do it, but you got to be really careful about it.
So we should just like stop.
Yeah, you should recognize this part. You should recognize this is a positive number, and this is always going to be true. So there's no reason to go any further. Okay. from our original problem right here. X minus 2 has to be greater than or equal to 0. X has to be greater than or equal to 2. Woo. Nice. Yeah. 3? Sure. Dean, did you get that one? Yeah, number 3.
Got part of it.
Nice. All right, these are polynomials. Polynomials always have a domain of all real numbers, okay, because they're polynomials. So they're always all real numbers. There's no radicals, there's no division, so you're going to have to watch out for that one. When you divide f, divide by g of x, now you have a denominator that can't equal 0. So, I mean, x can't equal plus or minus the square root of 1/2. Otherwise, you'll have a 0 in the denominator, and that can't be. Okay? Other than that, when you're adding, subtracting, multiplying, and dividing, the domains aren't going to change. Here, they want to draw your attention to the fact domains do change when you divide. That's why they made it a separate exercise. Okay? Anything else? Nice. Test week, although yours is only a one-day test. If I have time during the World Series, I will rewrite your test. Why? To make it challenging. How can you tell if a test is challenging? By the number of size delivered during said test. I'd shoot for about 15 size on this one. Wouldn't that be awesome? Yeah, it would. Yeah, I think you get a fair distribution then of grades. All right. We got fit. Ooh.
So do we have a review tomorrow then?
Yeah, over the practice test one day. All right, through the practice test, there's some odds you can do to practice. Okay. We've done enough of those in the homework, so I think we're good on those. Yeah, we talked about those. Dividing, domains. Oh, I went way too far back. Yeah, we just did, like I said, those, so we're in good shape. You want to do this one?
Yeah.
F of g of x and g of f of x. The only thing is this has a denominator. It's kind of cool, but what time is it? I think we better get going. Oh, this is a classic problem. I get this as a test question in the 124 class. It was great. I just took the slide and copied it onto the test. It was fantastic. I call on Nicole Brown. What is the function value of s if x is 1? Right. S of 1 equals 0. So now what is t of 0? Yeah. So the answer is 2. I love that. It's kind of like code.
It's so easy.
It is. I don't see why people get it wrong at all.
All you do is go to S of Y.
All right, try B on your own. It's kind of like brain game. Just do it without writing anything down.
Wait, what?
B. Did you get Dean?
2.
That's because you heard somebody. Did you actually do it yourself?
It's all in here.
I don't think so. C. Sure. T of 1 goes to 3. So that means you have to do S of 3, which goes to 2 as your final answer. Okay?
Genius.
No, you heard somebody. And you went with it. You had to make a decision whether you're going to go with it or not, and you did.
I just picked a random number and it was right.
Caleb? C. T of 1 is 0. You're correct. Oh, sorry. T of 1 is 3. Then you put 3 back in, you end up with 0 as your answer. Nice job. Nice job. There's one function with the domain of all real numbers that is both even and odd. Find that function. This is like one of those FYI moments. How you doing? There is one function with a domain of all real numbers that is both even and odd. That means it must have symmetry over the origin and symmetry over the y-axis.
Huh. Interesting.
It is.
Very interesting.
A line.
Ah, I got it. I think I do. It's weak, but it works, I think. Yeah, that's what I would go with. Same as y. Y equals 0. Yeah. I'd go with y equals 0. I don't know of anything else you could go with. Anybody got anything else?
No, that's
Tangent? No, not tangent. Absolute value? No. I'll go with that one.
Could it be x equals zero?
That's not a function. It's a vertical line. It wouldn't pass the vertical line test. Oh, we just did this one homework. We took the derivative of our spherical balloon, and we had to find the radius.
No, that's simply
Derivative is how something is changing at the instant of time. Okay? A spherical balloon with the inflated rate of 9 pi over 2 cubic feet per minute. Express the radius as a function of time, t in minutes, assuming that r is 0 and t is 0. What? I call on C. You just can't throw the I don't know flag up right away. You have to try and then throw the flag up. What is the, first of all, in physics, what is a rate? Right. I didn't ask what distance equaled. I said what does rate equal? D over T. In this case, we're going to do V over T.
why are you doing V?
Because we're working with volume and not distance. And we'll know the rate at which the balloon is increasing. Okay? So if you're blowing up a balloon, you would say it's increasing at 35 miles an hour. You'd say it's increasing at 35 cubic feet per minute. You have to change your idea of a rate. Okay? So, what's the equation for the volume? I call one of the Miller girls. All right? Not me means Carly. Carly, what's the equation of a sphere? What's V equal? Four thirds pi r cubed. 4/3 pi r cubed. I have no idea what I'm doing. I'm just trying to wing it. All right. I do not know, but we're getting closer. Express its radius r as a function of time in minutes. All right.
That'll be over T, right? Though.
It would be
So, right.
over p. I'm not done yet. Express the radius as a function of time, assuming that r is 0 and t is 0. I don't think that comes into play a whole lot. Because this,
I would go 9 over 2.
yeah, this whole thing would be 9 pi over 2.
Could be over 1.
I think it'd be over 2
Well, it's over 1 minute.
per minute. So that's just a unit rate.
So do you have to get like T equals for this?
I think you have to get r equals.
If we just but yeah.
4/3. You know what this means? This means you don't have anything inside in parentheses to shift the function left to right. I think that's what that means. I don't think you actually put it in to solve it the way you're thinking. So now I'm going to multiply the t over. No, I think you subbed the 9 pi over 2 in for the change in the volume. I think you sub the 9 pi over 2 in for the change in the volume, the V over the T. Right, but she's wanting to sub the 9 pi over 2 in for something else as well. I think we're set here because if you look right here, we only have one equation, and we want R equals, and we want T as our variable. So we can divide both sides by pi. That's kind of cool. Multiply both sides by 3. Get 27T over 2 equals 4R cubed. Divide both sides by 4. I need some room. Let's see what's supposed to do this. That was pretty good. You can take the cube of 27, the cube of 8.
Wait, where did we go from 4/3 pi?
What?
Okay, 4/3 pi r cubed equals 9.
Right.
2 times t. Where's that?
I divide both sides by pi. Divide by pi. Here I multiplied both sides by 3. And here I divided both sides by 4. Or if you want to look at it, you can say multiply by a 4th. Same thing. So what's the cube root of 27? C. Time to bring it home. Cube root of 27. Cube root of t? And the cube root of 8? 2. That would be in feet per minute. No, I think the radius is just in feet per minute.
Can you slow down a little bit?
I think volume's in cubic. What?
She's not a fan.
Oh, this is like a little glimpse into calculus, because I got the same answer in the other book. Only we did it a different way.
An easier way, probably.
Well, yeah, we did derivative.
Oh. That'll make sense.
We found the radius and then divided and got the answer.
Oh, okay.
Oh, yeah, they're not great.
That's okay. Olivia spelled it out for you. Yeah, Olivia, not that. See? All right, let's try another one. That was fun. Yes!
Oh my
The telephone cable. If you're a Gilligan's Island fan, this is a great problem.
It's Josh's turn. He's not this one.
He's still digesting. He's fine. You gotta wait an hour after.
He's not swimming.
An hour. Ready? A 100-foot long cable is submerged in the Burmese. No, that's a different problem. Diameter 4 inches. There's something that uses geography later on in my calc book. This is 100 feet. 100 foot. Yeah, right, that's what I do. No! These problems are coming up at the same time in the same part of the year. It's unbelievable. Radius is 2 inches. And submerged in seawater, which is very corrosive due to the salt, which you learned in physics. The cable decreases. Anytime you have a rate decreasing, you have to negate it in your work. So it's negative 750 square inches per year. The surface area of the cable is decreasing. Not the ends of the cable, only the surface area of the cable. Yeah, but no. It just says it's surface, not the ends. So it's not getting shorter, it's just getting thinner. Okay? You don't have the math to worry about both at the same time right now. Let's just worry about one, then we'll worry about both later. So you negate this because it's decreasing, that's why it's underlined. Express the diameter of the cable, D, as a function of time in years. Disregard the corrosions at the end. So we need an equation for the surface area of what kind of geometric shape? Cylinder. Not everybody at once. You have geometry credit, right? Surface area
Still,
of a cylinder.
SA.
2 pi RH. That equals the surface area of a cylinder.
I give up.
Okay? That's an important skill that you know where those formulas are because they're in the same place in the purple book. Now, if I take any measurement and put it over time, it becomes a rate. So, I put this over time, and that becomes a rate. And I put this over time, it becomes a rate. So now I got the negative 750 that goes in for right here. The negative 750 per year. Is it per year? Yeah, per year. Equals. Express the diameter. The diameter is equal to twice the radius. So R equals D. I put in my equation 2 pi D over 2. H is 100, isn't it? It's 100 feet long.
Yeah.
Is that right, Dean?
Exactly.
Over time. Now you're supposed to solve for D.
Don't you know the time?
You don't know how. No, you want to put in something like 6 months and figure out how fast the diameter is changing, or something like 2 months, how fast the diameter is changing. Yeah? Yeah, that's in feet, and this is in inches. So I would say you're absolutely right, that'd be 1,200 inches. There we go. Now we're all in good shape. Those twos divide off. I'm thinking I need another 2 somewhere, or another T somewhere.
Isn't that where your spirit is?
So I got 1,200 pi D equals negative 750 T inches squared per year. If I multiply the T over, I must look this one up. This one doesn't look quite. Yeah. Oh, that got accounted for with the year as far as the change in the rate. The whole thing became the rate. Okay. So that means D equals negative 750 T over 1,200 pi inches squared per year. You can divide. You can simplify a little bit. I don't know what's negative 750 over 1,200. Divide by 0. Divide by 25. No, you can't. Divide by 5. Negative 25, 5, 2, 4 pi T inches squared per year. I don't know, I'm not really liking that answer a whole lot. It doesn't look familiar, but that's okay. What? I'm going to look that one up. All right.
No, but it's not negative 25.
Oh, it's negative 45.
Huh? No, it's negative 75 divided by 5 is a negative 25.
Oh, it's 35, isn't it? No, 15. There you go. Thanks. Eric probably caught that at home, didn't he?
You divide by 3.
Divide by 3? Nice. Negative 5/8 pi T inches squared per year. Nice. Anyway, this will give you some practice going into the word problems and practice test tomorrow, and you can do the odds for some more practice. I think I'm going to collect the odds this time so you can do it on your own. Is that it? Oh. Well, these are easy. F of g of x. I'll just do one of them. So g of x would equal the inside, and f of x would equal the outside. That's basically about it.
That's what you do.
Yeah. Find a composite function form, so you have to list two functions in the rule, and I always just put parentheses someplace. There's more than one answer for this, if you want to get,
Your answer would be f of x equals.
right, it'd be all three of them. I have my rule and I have my two functions defined to come up with the result. Okay? Yeah, you could come up with, like I said, if you put the parentheses in this place, around the x to the fourth, I don't know, you could do it like this. This would be better. X to the fourth around this. So you could have f of g of x, and f of x would equal the fourth root of x minus 16, and g of x would equal x to the fourth. Okay. So you could have it like that. See how I changed it? It just depends on what you see and how you look at it. Okay? All right. Surely that's got to be enough. I'm not doing that one. That's too easy. So I got the parentheses in it. All right. Let's see if there's any like big problems to worry about. I don't think so. Camel 52. There's a balloon.
We already did it.
Yeah, hot air balloon.
We did it.
No,
Where?
Number 49.
Oh,
Nice. Oh, you do that in homework.
You can do it now.
Good. How much time we got left?
A lot.
No.
We should take a grade.
Let's do this. Not that much time.
No.
I like when everybody talks to me, three people at a time like that, I can understand them. And they keep going. I know, that's where Charlie Brown gets it from the teacher. Yeah,
We have 9.
9 minutes, enough time to do this one. I used this one in calculus just yesterday. We found the rate at which the string was leaving. No, we found the rate at which the balloon was rising. And it's the same problem, except this direction changes right here. The balloon is released at a rate of 5 feet per second. So this is 5 feet per second. The pulley, its rope is 20 feet away. Express the altitude h as a function of time. It's classic. What's wrong? Well, what's the relationship between all three of those? Yeah, it's a Pythagorean theorem. 20 squared plus h squared equals c squared, or r squared. Let's call it r.
So we just put 5 feet per second.
What?
Like, why can't you put that in there?
That's not a distance, that's a rate. These are lengths. Huh? Now the 20 is not changing, is it? No, so that's changing and that's changing. Now you have distance over time, now you have a rate. Calculus is really easy. In this class, it's a little bit difficult because I can't do things that you don't know yet. So I'm always stopping. Oh, don't know that. So express h as a function of time. So I'm going to subtract this over the 20, of course. Okay. So you have h squared over t equals. Let's see. That distance is 5 minus 20 squared. See, something's not right about that one. I can't subtract that and that to get a negative number. See, in calculus, I just did it as 2rr prime. And it's really easy, 2h prime. There's got
Yeah, definitely.
well, there's got to be a small bridge to cross to go back to do this problem.
Maybe we should look up 16.
Yeah, why don't you do that? And I will, I'll look up the other one and see if I got it right. Number 52. All right? Sounds good. There's some odds. I don't know, you should probably get through at least,
49.
no, do some of these, so it's probably 55. Okay? So page 196, 20, what, 9 through 55 odd, something like that? Okay? All right. Tomorrow I'll go through the practice test for your test on Thursday. Make a note on your calendar. Tuesday is the day that Miss Ryan's planning on coming to bring you forms. So if you know you're going to be gone on Tuesday, make sure you get the forms from Miss Ryan. She's going to give instructions during your class period and give you the forms during your class period. It won't take the whole class period on how to go about this dual credit option, okay? Next year, if you want to try the dual credit, it's going to be a lot easier because you filled out most of the paperwork.